So just a quick recap of the things we have learned about vectors till date. So we saw that as far as vector operations are concerned, if you represent a vector V as some multiple of vector A, where n is a scalar, and A and B are vectors, it means that, for example, if vector B is, let's say, some positive scalar like 5 times vector A, it means that magnitude of vector B becomes 5 times magnitude of vector A. And the vector B is along vector B. It is parallel to it. Whereas, for example, so this is one of the first type of operations that we learned last time. Whereas if, for example, we have a relation that vector C is, let us say, minus 0.6 times vector E, it means that the magnitude of vector C is 0.6 times the magnitude of vector E. But the minus sign here indicates that direction of C is opposite to direction of E because of the minus sign, or it is what we call anti-parallel. So this is one of the first things that we learned last time. Okay, then we went on to see that the triangle law of vector addition. That we saw that if, for example, we have two vectors which are represented by these kind of arrows, such that the angle between them is this angle theta over here. So if magnitude of vector A is given by the symbol A known to us, magnitude of vector B is given by the symbol capital B known to us, and theta is known to us, the angle between A and B, then we can find the resultant sum of A and B by constructing this triangle in which we draw the vectors A and B head to tail like this, one after the other, just as if they are displacements. Theta becomes this exterior angle, and in this triangle now the resultant sum of A and B becomes this particular vector. This now represents E plus B. And suppose this angle is alpha, we can see that the magnitude of the resultant, which is nothing but magnitude of A plus B, we derived was given by this formula, which is called the triangle law formula, is square root of E square plus B square plus 2AB cos theta, and the angle alpha is given such that tan alpha is equal to B sin theta upon E plus B cos theta. So this was the more important thing that we learned last time, the statement and the diagram of the triangle law. So this whole thing together is called the triangle law of vector addition. And one more important thing that we saw is that this angle can also become obtuse. So we saw that if it becomes obtuse, then we use the special trigonometric relation for sin theta and cos theta. So we also saw that for theta being an obtuse angle, that is greater than 90, less than equal to 180 degrees, we use the formula, rather the formulae, that cos theta is minus of cos 180 degrees minus theta, and sine theta is positive of sine 180 minus theta. And from the ratio, you can also see that it requires negative of 180 minus theta. So this was some of the important things that we saw last time. So I'm just giving you a quick recap, then we'll do some questions based on this. So triangle law of vector addition is important. So there is a little bit of issue with internet connectivity today because of the weather conditions. So in case there is difficulty, don't worry. As usual, the video lecture will be available to you. So all of you are clear with this? Okay. So far, these things. So the statement of triangle law, that magnitude of a plus b becomes root of a square plus b square plus 2ab cos theta. And this formula tan alpha is b sin theta upon a plus b cos theta. And further, the special application of it when theta becomes obtuse, because two vectors can also be in this kind of relationship. That vector E is like this, but vector B is at an angle like this. So you can see in this case, the angle between them is an obtuse angle, whereas in this case it was an acute angle. So when your situation is looking like this over here, then you will have to use these formulae to substitute the value of cos theta and sin theta in this one. And in that diagram, you can see that E plus B will become this. The resultant will become that one. So depending on the magnitudes of A and B and the angle between them, your triangle can look like this one if it's an acute angle, or it can look like this one if it's an obtuse angle. So let's quickly work out some examples now. Let's go on this again. So here's something for you to calculate. So magnitude of A is equal to 10 units. Magnitude of B is equal to 20 units. And theta, that is the angle between A and B, is 120 degrees. So find the magnitude of the resultant, A plus B mod, and also find the angle of A plus B with respect to the vector E. That is, typically we call that angle alpha. So we have to find these. So this is a direct application of the triangle law statement. Just work this out with me and send me the answer. Yes, very good, Aman. Khushi, check your calculation again. Yes, Akshat, correct. You have to just use the formula better. Root of A square plus B square plus 2 cos theta, that formula. In this case, all you do over here, you use the formula that mod of A plus B given as this. In this, we'll substitute A as 10, given to us in the question, B as 20, given to us in the question, and theta as 120 degrees. So theta is 120 now, means that cos theta will be given by that formula. It is minus of cos 180 minus theta. This is the formula for obtuse angle. This is what we discussed last time. So it becomes minus of cos 60. So that becomes minus 1. So cos theta has to be substituted as minus 1 in this formula. So magnitude of, yes, correct question. So magnitude of A plus B now becomes root of 10 square plus 20 square plus 2 into 10 into 20 into minus 1. But you can see this becomes 100 plus 400 minus, so it becomes square root of 300 or 10 root 3, or you can approximately write it as 17.32 also. Okay. But this is fine, you can just leave the answer this way. So it's good. So this is the answer we are looking for the first part. Magnitude of A plus B. Yes, so that's correct. Okay. Now we have to find also the angle alpha. So for that part, we have to use the other formula, the tan alpha formula. Yes, Aditya, if you have a doubt, just ask me. Dushyant, correct. Nishchal, you will have to check your calculation. Dushyant, your value of angle is correct. Yeah, Idanshu, this is vectors lecture number 3. So let me solve this part. Most of you are getting correct. So we'll use for the second part, we'll use this formula. Tan alpha is B sin theta upon A plus B cos theta. So this means again we have to substitute A as 10, B as 20, and theta is 120. So again, cos theta becomes what we saw earlier, minus half. Sin theta. Sin theta, which is sin 120, will be positive of root 3 by 2. Okay, so remember this formula that sin 120 will be positive of sin 180 minus 20. So it will be positive of sin 60. Whereas cos 120 we just saw earlier is given by the formula that it is minus cos 180 minus theta. So that's why. So this value for sin theta. So just substitute that now in this. Substituting, we get tan alpha as d sin theta, so that is 20 into minus root sorry, into plus root 3 by 2 divided by A plus B cos theta. So 20 into minus half. You can see it is 10 root 3 divided by 0. So it is undefined. Okay. So tan theta is undefined, or tan alpha rather is undefined. Means that alpha is 90 degrees. Okay, so this is the full calculation of this. Yeah, Iitanshu, don't worry. I will be sending you the video recording of the entire lecture. So the part that you missed before this was just a recap of what we learned last time. We started with this question only, so you can just pick it up from the recording. Yes, someone, your answer is correct. Yes, Prince, you got that correct. Okay, so I think all of you are. Yes, I will be sending every lecture session notes. Don't worry. Thank you. Every lecture you will have a recording and session notes and all that. Now let's move on to another question, which is based on. Remember last time we also talked about some important triangles. We saw that you have a triangle which has sides. I mean right angle triangles, special ones. We're talking about this triangle where 53 degrees and 37 degrees, or if you invert this triangle, these type of triangles, right angle triangles with 37 and 53 degrees, if their sides are always proportional to 5x, 4x, and 3x. Okay. So they could be, for example, 3, 4, 5 triangles, or they could be something like, let's say 12, 16, 20 type of triangles, or 16, 20, 15, 20, 25, these type of triangles. The sides will be like this. Here x is 1, here x is 3, for example, but this is 4. This one x is 5. So triangles of this type, whose right angle triangle whose sides are of the ratio 3:4:5, have these kind of angles. You can write them as 3, 4, 5, or 3x, 4x, and 5x. Doesn't matter. Alright, so the important thing here is that cos 53 degrees is p by 5, which is the same thing as sine 37 degrees. Okay, and cos 37 degrees is 4 by 5, which is the same thing as sine 53 degrees. Okay. And tan 37 is p by 4, which is the same thing as cot 53, or cot 37 is the same thing as 4 by 3, which is tan. Okay. So these are some new values that we had learned last time. Apart from the standard values of 30 degrees, 45 degrees, 60 degrees, 90 degrees, zeros that you already know for sine first. Now you also know 37 degrees and 53 degrees. So these are some important values. So especially in the physics part, you will have a lot of problems which have angles of this type, 53 and 37 degrees. So you should remember these values. So let's look at a question now involving vectors and this. So next example is like this for you. This is the vector E, and this is the vector B. Now let us say B has a magnitude of 15, and this angle is 53 degrees, and E has a magnitude of 3. So mod A is equal to 3 in some unit, and mod B is 15 of the same units. And the geometry is as I've shown over here. So you have to find the magnitude of E plus B with respect to the vector E. Just try this out. Yeah, anybody got the answer? Okay. So again, you have to use the triangle over here. From the diagram, you can see that the angle between A and B is how much? It's 53 degrees. Because A is along the x-axis and B is at 53 degrees to the x-axis. So again, you can see that the angle between the vectors A and B is 53 degrees. So again, you can see that magnitude of A is 3, magnitude of B is 15, and the angle between A and B is 53 degrees. So just use that. So just make use of this. So here, for example, if you were to draw A and B one after the other, it would be like this. this angle 253 degrees. Okay. So the resultant sum which you are trying to find out, so that you don't have to do anything else. You just apply the formula. You don't have to do any geometrical construction or anything. You just apply the formula. So mod of a plus b become root of a square plus b square plus 2 into a into b into cos 53, which you know is cos 53 get the similar b by 5. Just apply that. So this is becoming 9 plus 27 to 54. This will become square root of 283, which you can write as 144 into 2. You can also say that square root of 12 square. 12 into 2, you can do the answer this way, or you can approximate this as 12 into 1.41. But just now I gave you the value for 53 ना बच्चों, इसके पहले मैंने क्या कराया अभी? इसी one, you're not writing the notes, it means but this is enough. We can just leave the answer instead. So this is becoming mod of k plus b. Now similarly use the tan alpha. Just one moment. I showed you the value of the of internet connectivity. Yeah, students, there is a bit of internet connectivity problem because of, I guess, the weather conditions today. So don't worry, I will go slowly and keep explaining again. Plus, you will get the video recording later. There's a lot of bit also. Yes, correct. We get tan alpha as 1, not as 1. We get tan alpha. Substitute b sine theta upon a plus b cos theta. That is 15 sine theta upon 3 plus 15 cos. Okay. So that is 15 into 4 by 5 divided by 3 plus 15 into 3 by 5. So that is 12 divided by 3 plus 9. There's nothing but unity. So alpha is coming to be unity, which means alpha is 45 degrees. So alpha is 48, 45 degrees. Okay. Okay, so these are various important examples of the application of triangle law. Okay, so hope the final answer is clear to all of you. You're getting alpha as 45 degrees and we are getting mod of a plus b as 12 root 2 in this case. All right, moving on now. Two important properties, okay, which come from this formula. If theta is equal to 0, that is they are parallel vectors. Okay, that is A and B are parallel vectors. Then mod of A plus B, as you can see, becomes root of A square plus B square plus 2AB, because you know that cos 0 is unity. as you can see, it becomes A plus B. Magnitude of the vector sum becomes the sum of the magnitudes for theta equal to 0. Okay, and mod A plus B. For not each any mod of A plus B will be less than the sum of their magnitudes. Okay, so why this happens? Because for theta, cos theta will be less than 1. So this we can this point. So one value can now the theta is equal to. Okay, so students, hope you have understood this now. That if you put the value of theta as 0 in this formula, as you can see, cos 0 is 1. So what does the right hand side become? It becomes root of a square plus b square plus 2ab. So that is nothing but a plus b ka whole square. So its square root becomes how much? A plus b. So magnitude of a plus b becomes magnitude of a plus magnitude of b, in which case whenever theta is 0, or in other words when the vectors a and b are parallel to each other. For any other value of theta non-zero, what will be mod of a plus b? It will be less than mod of a plus mod of b. So just make a note of this, then we'll understand the application of this. Okay, students, so this particular statement is that this is less than a plus b for all other values of theta. It is also sometimes called the triangle inequality. Okay, so let's understand this with an example. If magnitude of A is 5 and magnitude of B is equal to 7, then magnitude of A plus B can never be which of these options. Okay, let's say there's a multiple choice question. So understood the question. You have to find out that which of these options can never be the magnitude of A plus B. So which should be the correct answer now? Yes, correct. Akshat, your answer is correct. नहीं, C हो सकता है रिमझिम. C and D both can be there. The one it cannot be is 16. B. Yes, Mr. Yes, Prince correct. Okay, because you have to understand here that since magnitude of A plus B is less than equal to A plus B for all possible theta. Okay. Why? Because we saw that for theta equal to 0, magnitude of A plus B is equal to A plus B, which in this case is how much? 12. Whereas for any other theta, for any theta not equal to 0, magnitude of A plus B will be less than or less than 12. Okay, because cos theta will become less than 1. Whereas here we know that cos 0 is equal to 1. So now what we can say that given that magnitude of A is 5 and magnitude of B is 7, magnitude of A plus B in general is less than equal to 12 for all theta. So even if I don't know the angle theta between them, I can say one thing, it cannot exceed 12. 12 भी हो सकता है कब, जब थीटा का वैल्यू 0 हो, बट 12 से ज्यादा नहीं हो सकता. Yes, so it is less than equal to 12 in general because theta can be 0 also. No? It can be 0, it can be non-zero also. If it is non-zero, it's less than 12. If it is 0, then it's exactly 12. But no matter what value of theta we take, it cannot be greater than 12. Okay, so no matter what value of theta we take, it cannot be greater than 12. That is the important thing. Okay, so that's how we are saying that it can be 12, yes. It can be 10, yes. It can be 2 also, but it cannot be 16. Now, for example, let's do a reverse of this question. Okay. So, hope this question is clear to all of you. Yes. So, 16 क्यों नहीं हो सकता है? Hope all of you understood. Why it cannot be 16? You understood. Now, in case you're wondering, 10, how can it be 2, for example? Okay, so let me show you an example. So, let's say we ask a reverse of this question, that the next example we are saying is, again, magnitude of A is 5, magnitude of B is 7, and yeah, people still having some internet issues, getting disconnected again and again. Yeah. So let's look at the next question again. Okay. So suppose magnitude of A is again 5 and 7, and given to us that magnitude of A plus B is equal to 2. Okay. Now what we have to do is we have to find theta, the angle between vectors A and B. Just try this out, people. try out this question now. So again, which formula you will use over here? The formula of triangle law. But इसमें भी unknown quantity क्या है? Theta है. What is the known quantity? A plus B is magnitude is known. So left hand side you know of the equation. But right hand side में the value of theta is unknown. So you have to solve it for theta. So just write the statement of triangle law and try to solve it first for cos theta. And from cos theta you will come to know the value of theta. Correct. Aman, your answer is correct. Good. Rest of you can also get it very easily. Okay. Just write the statement and you will understand. Yeah, so hope all of you are getting the value of theta now. So many of you got it correct. Let me solve it fully. So you'll get theta as 180 degrees, people. Okay, you should get theta as 180 degrees. Let's understand how that happens. Just apply the formula. Mod A plus B is root of E square plus B square plus 2AB cos theta. So यहाँ पे mod A plus B is given to us as 2. 5 square plus 7 square into cos theta. Okay, this one. Now square both the sides. So we can write 2 square is equal to 5 square plus 7 square plus 70 cos theta, right? Or we can write cos theta as 4 minus 25 minus 49 by 70. Okay. So that works out to be how much? That works out to be minus of 70 by 70. Or cos theta works out to be minus 1. So cos theta is equal to minus 1 means that theta is equal to how much? It's 180 degrees. So cos 0 is 1. That means cos 180 should be minus cos 0. So that should be minus 1. This is again coming from the formula that cos theta is minus cos 180 minus theta. So in this formula, you just put theta's value as 180. So that will give you that cos 180 is minus cos 0 minus 1. Okay, so hope this is clear to all of you people. So finally, the conclusion here is that theta must be 180 degrees. Okay, so that means A and B are opposite or anti-parallel in direction. Okay, so just make a note of this. Right. So through this example, we actually learn another important property of vector addition, and that is the minimum value of A plus B. Okay. So from this we understand that for theta equal to 180 degrees, cos theta equal to minus 1. So this is the minimum possible value. Just a minute. Just a minute, people. My software is getting hung because of internet issues again. So, just a minute. Yeah. So this is the minimum possible value of cos theta. So that means magnitude of A plus B is greater than equal to root of A square plus B square minus 2A for all theta. Because उसका cos theta का minimum value कितना है -1 है और maximum value कितना है +1. So when you combine these two, or in other words, we can say that magnitude of A plus B is less than equal to A plus B and greater than equal to A minus B. Because this statement also means that difference of A and B, because the A minus B whole square. Okay. So combining these two statements that we've seen earlier, now we get this particular thing, equation that. So this is the minimum possible value, and this happens for theta equal to 180 degrees. And this on the other hand is the maximum possible value, and this happens for theta equal to 0. Yeah, I'll show you the full slide. So just like we had analyzed for the maximum value, that occurred when cos theta was plus 1. That was when theta was 0. Similarly, here we are analyzing for the minimum possible value, and this occurs when theta is equal to 180 degrees and cos theta becomes minus 1. So now this last equation that we've got this by combining the theta equal to 0 case and the theta equal to 180 case. This is why we've written the theta equal to 180 case, and earlier we had written theta equal to 0 case. So combining the two, you see that is what happens. Yeah, Itanshu, the reason for this is the range of values of cos theta. No? Why this inequality exists? Because cos theta cannot be greater than 1 and cos theta cannot be less than minus 1. So that is the technical reason why this happens. Or if you think logically, for example, suppose A is a displacement of magnitude 10 kilometers and B is another displacement but of magnitude, let us say, 5 kilometers. Now combining A and B, what is the maximum possible displacement you can get? So maximum possible displacement will happen when you don't change direction. So maximum will happen when A is like this and B is continued in the same direction. So in that case, A plus B will have a magnitude of how much? 15. But can you have more than 15 for the sum of these two? Not possible. No? Whereas minimum kab hoga when A and B are opposite to each other. So if A is a displacement like this of 10 and then B becomes a displacement exactly opposite. So you are actually taking a U-turn and coming back 5 kilometers. In that case, your resultant displacement will become how much? Your resultant displacement will become only 5, the difference of the two. So can it be less than 5? No, because you're combining 10 and 5. So combining 10 and 5, the minimum possible value is when they are opposite to each other. And in that case, you're going forward 10 and then coming back 5. So your displacement has to be a minimum of 5. So that's the logical reason why it cannot exceed A plus B and cannot be less than the difference of A and B. So if you think about logically what is the reason for this inequality, you can just take an example of displacement and understand it this way. So that's why this is taken as mod. If A is lesser than Akshar, it will still be a magnitude. This is taken as mod of the difference. So for example, यहाँ पे अगर B 15 होता, तो maximum value कितना होता? 25 होता, but minimum 5 ही होता. But now, hope you understood, Akshar. See, technically, this statement, this thing, it's root of A square plus B square minus 2AB. So that is root of A minus B whole square. Now, A minus B can be a negative quantity also. No? So when we write this, we'll have to write this as mod of A minus B, not just A minus B. That is why. So if A is greater than B, then it's okay. If A is less than B also, it will come with a plus sign only because it's a mod. Okay. So that's just a matter of mathematics. For example, if I write 3 minus 5 ka whole square ka square root, I'll not write it as minus 2. It will become square root of minus 2 whole square. So that will be 2. So anyway, all that aside, now the next thing we come to is difference of two vectors. So this is again another type of triangle law, but you can say this is second part of triangle law. Part B, okay, or part 2. So if two vectors A and B are given to us in geometrical form like this, the angle between them is theta. Now A minus B, you want to find this out. So the method is that A minus B can be written as the sum of A with the vector minus B. So you can apply triangle law, but the thing is that you're not adding A and B. You're adding the vector minus B with A. Okay. So basically, you have to understand what is the vector minus B. It is a vector of same magnitude as B, but opposite direction. Okay. Just think of it like this, that the vector minus B is like you're multiplying minus 1 with the vector B. So because you are multiplying a minus quantity, the direction becomes opposite. But the quantity you're adding is ultimately having a mod of 1. So its magnitude remains how much? It remains the same. So mod of minus B is the same as mod of B. But the direction is opposite. So now let's understand what we're doing geometrically. So if this was the vector E and this was the vector B, such that this angle here was theta. Now what will be the vector minus B? Minus B will become this vector. It will be a vector that is exactly opposite to B. So anti-parallel, but of same length, so same magnitude. So this will be the vector minus B. It should be the same length as the vector B was. So this arrow should have the same length, but it should be exactly in the opposite direction. So it should be pointing in a direction like this, where this angle is theta. Okay. So now I want to do the vector sum of A and minus B. So A plus of minus B karna hai mujhe. So I'll take this vector and draw it first, and then to that vector I'll add which one? I will add not the first one but the second one, which is the vector minus B. So I'll pick up that vector minus B and place it over here. So this is the vector of magnitude B, but its direction is opposite to B. So B's direction, remember, was like this. So minus B का direction क्या हो गया? उसका उल्टा हो गया. Exactly उसका opposite हो गया. So originally, remember, this angle was theta. Theta was the angle between A and B. So the angle between A and minus B becomes how much? It becomes 180 minus theta. It becomes this angle, which is 180 minus theta. Okay. So now in this diagram, what is the sum of these two vectors, A and the vector minus B? It is this third side of the triangle. So this is becoming this quantity. Okay. This is becoming the vector A minus B. And let's say this angle is beta. Okay. This is what we wanted to find out. So this is what it is. Okay. So here we have to, of course, understand one thing, that theta was the angle between the vector A and the vector B. Therefore, the angle between the vector E and the new vector minus B is how much? It is 180 minus theta. Okay. This is, so that's why this angle is 180 minus theta. Okay, so just make a note up to here, and next we will see how to apply the steps of the same triangle law we've seen earlier to come up with a formula for the difference of A and B. Okay, so just make a note of this part first. Okay, so people understood up to this final step here. So what we are doing now is, from the vector B, we are constructing the vector minus B. That is the vector opposite to the vector B in direction, but of the same magnitude. So once we have constructed the vector minus B, then what we are doing is we are adding the vector minus B to the vector B. We are adding vector minus B to the vector A. Okay, so just give me a minute. I'm refreshing the board because some symbols have gone here and there. Just give me a second. I'll put on the whiteboard again. Just a minute. Okay. So that's why, since this angle was theta, so over here, this angle will be theta. So that's why this angle will be 180 minus theta. So this last point is important to know, that if the vector B is making an angle theta with A, then its opposite minus B will make how much? 180 minus theta. So now we are doing this operation. So next up, just apply the formula. So we are doing A plus of the vector minus B. So by triangle law, उसका magnitude कितना हो जाएगा? It will be root of A is magnitude square plus minus B vector's magnitude square plus 2 times mod A into mod of minus B, but into cos of which angle? 180 minus theta, not theta. Understand this point now, because here we have to put the angle between which vectors? A and minus B, not A and B. That's why we have to replace theta with 180 minus theta. Okay. Now use the formula cos of 180 minus theta is minus cos theta. Okay. And of course, the magnitude of minus B is the same thing as the magnitude of B, which in short form we can just write as B. Okay. So this thing now becomes mod of B minus B. On the other side, wherever there is mod of minus B, you just replace it with capital B. Okay. And the cos 180 minus theta becomes minus cos theta. So this becomes minus 2AB. So this becomes our formula for magnitude of A plus B. Oh, sorry, magnitude of A minus B. So this is like the triangle law's second part. Triangle law, part B. It gives you the difference of the two vectors. Part A gave us the sum of the two vectors. So easy way to remember the formula is कि sum में यहाँ पे plus 2AB cos theta आता है, difference में minus 2AB cos theta. Okay, so people hope this is clear to all of you. So let's look at a quick example. Suppose we have magnitude of vector E is equal to magnitude of vector B is equal to, let us say, 5 units, and theta is equal to 60 degrees. Then find magnitude of A plus B and magnitude of A minus B. So find both of these. Just try this out. When you find out by the formula, when you finish that part, also do this, that find out both by, yeah, Khushi, that's correct. You check your answers. Yeah, Aman, Khushi, and yeah, both of you got the first part correct. Aman, second part is also correct. Dushyant, correct. Nishchal, correct. Very good. So when you complete working the numerical part 1 and 2, also draw the triangles that represent both of these. Vimjim, correct. Good. Akshat, correct for the second part. Yanuj Singh, correct. Oh, Anuj, just check your calculation once. You are getting it in reverse. Okay. Dushant, correct. Aditya, correct. Vimjim, correct for the second part. So just use these formula now. Correct. Magnitude of E plus B is root of E square plus B square plus 2AB cos theta. So in this put E equal to B equal to 5 and theta equal to 60 degrees. So cos theta equal to half. So when you do that, you will get this as root 75 or 5. Get for the second part, use the formula root of A square plus B square minus 2AB cos theta. If I use the same values as above, so you'll get this as 25 plus 25 minus 20. So we get that as 5. So in this particular case, mod A plus B is 5 root 3 and mod A minus B is 5. And now you see when you draw the vector triangles to represent this, yeah, no understood. Okay. So you got it correct. That's good. So when you draw the vector triangles, you see it's very easy to justify why this is the case. Yes, very good. Aman. That's correct. In the second case, it will become an equilateral triangle. Aman. That's why when in the first case, it will be an isosceles triangle. So your vector A and B are basically something like this. The vectors of same magnitude. But such that the angle between them is 60 degrees. So when you draw the triangle for A plus B, you will see that we get this sort of a triangle. This side is equal to this side for the vector sum. So that is coming out to be 5. And you can even work this out using geometry. You can drop a perpendicular here and you can use the fact that this angle is equal to this angle. And their sum should be equal to 60 degrees. So 2 alpha is equal to 60 degrees. So alpha is equal to 30 degrees. So mod of A plus B, you can also work out from trigonometry here. Each of these half triangles that I've drawn by dropping this perpendicular, they have the same base. Let's say this is x, so this is also x. That should become 2x. So 2 times 5 cos 30. That's how it becomes 5. That's another way to understand it just by the geometry. Whereas if you're doing the vector difference of these two, now for the difference you'll have to draw the triangle like this. The vector E is the same. So 5. But now you draw the vector minus B. So minus B कौन सा vector हो जाएगा? ऐसा होगा. Such that this angle is now 120 degrees. So in other words, the interior angle is between 60 degrees and this side is equal to this side. You can see that it's very easily becoming an equilateral triangle. So it's very easy to understand why this side now, which is A minus B, it's also having magnitude 5 because this angle is equal to this angle. That is the solution. So these are the corresponding vector triangles that represent each of these operations. Okay, so just make a note of this, guys. Right, so hope this is clear to all of you people. So this finishes our first part of the geometrical type of operations involving vectors. Now we move on to a second way of interpreting vectors, which is called the component method. So now we come to the component representation of vectors. So in this method, instead of using geometry, where in geometrical case we used an arrow to represent vector, we make use of a coordinate frame, a rectangular coordinate frame. So component representation is basically a representation of vectors in terms of a Cartesian, or what we can also call a rectangular coordinate frame or coordinate axis. Okay, so that is the method of representation. So instead of using things like trigonometry and Pythagoras theorem and things like that, we will be making use of coordinate geometry concepts that we need. So first and foremost, we'll have to define. So we'll start with two-dimensional situation where we define two axes, the mutually perpendicular x and y axis. So when we do this representation in 2 dimensions, what in short form we call 2D, we do the representation in terms of XY axis, where X and Y are mutually perpendicular axes. So in order to do the representation, the first thing we do once we've defined the X and Y axes, we define what we call standard unit vectors, or they are also called base unit vectors. Given by the symbol I cap and J cap. So if you've seen your module in physics, you would have seen a lot of questions which are based on these kind of symbols, I cap and J cap. So what do they mean? So I cap is a very standard quantity. It's a standard unit vector, which is defined as a unit vector pointing along the positive x-axis. That is how we define the I cap. It's a unit vector which is pointing along the positive x-axis. Right, this properly. This is a standard notation. We use it everywhere. Whereas this is a unit vector along the positive y-axis. So back in this diagram, the vector I cap will be like this. It will be a vector pointing along the positive x direction and of magnitude unity of 1. Similarly, the vector j cap will be a vector pointing along the positive y direction. And again, its magnitude should be unity of 1. Similarly, if we take a vector pointing along the negative y-axis, it will become minus j cap. This will be the vector minus j cap. So it is pointing along the opposite direction to j cap. So it's along the negative y direction, but its magnitude is unity. Similarly, a vector which is pointing along the negative x-axis and its magnitude is unity will become minus I cap. So minus I cap will be this sort of vector. We'll just make a note of this definition first, then we'll see how to represent a vector using component notation. So component representation of a vector or of vectors involves making use of a Cartesian coordinate frame. So when we're talking about a 2-dimensional Cartesian coordinate frame, we use the standard XY notation, where now in addition to the XY axis, we have 2 other standard quantities, and they are nothing but I cap and J cap. There is a unit vector along the positive x direction and a unit vector along the negative x direction. Just make a note of this first. Yeah, so that is what we'll see. Vectors can point everywhere. So we won't talk about only vectors along I cap and J cap. This is just the definition of I cap and J cap so far. We haven't yet come to how to represent any given vector using the component notation. We are coming to that next. So far, friends, we have only defined 2 things, I cap and J cap. So I cap, it's a standard type of unit vector. Uska magnitude 1 है and its direction is along the positive x direction. Similarly, J cap, its direction is along the positive y direction. So naturally, minus J cap becomes along the negative y direction. Minus I cap becomes along the negative x direction. Okay, so understood. So far, we've just done this. We've just defined what is I cap and J cap. And it is defined according to our system of XY axis. Okay. So for example, if I've for some reason taken y axis like this and x axis like this, I need not always take it, but they have to be mutually perpendicular. Then I cap will be like this, J cap will be like this. It's up to me how I take my x axis and y axis depending on what depending on what problem I'm solving. Next thing, let's understand. Once we've defined our I cap and j cap, now any vector in the xy plane is now represented in component form as, so any vector is now represented by an equation like this, that it is some scalar quantity which we can write as ax multiplied with I cap plus some scalar quantity ay multiplied with j. So this is now called the component representation of a vector. So this is vector E represented in what we call component form, where the term Ex and Ey is very specific, where Ex and Ey are scalars called the x component of vector E and y component of vector E respectively. So just first note down this definition of what is x component and y component. Then we'll see how this vector looks in the diagram. We'll look at an example and we'll understand. Okay. So once you've defined I cap and j cap, any vector is just written as some number ax into I cap plus some number ay into j, where those two numbers ax and ay, which are basically scalar quantities, they are called the components of the vector, the x component and the y component respectively. So we are still talking about just definitions. Okay, so written down the meaning of ax and ay. I mean the definition of ax and ay. Now let's understand what is the relationship between the vector's magnitude and direction with respect to ax and ay. So let's look at the geometrical meaning of ax and ay, that is the components. So for that, what we'll understand is with respect to my xy system, with respect to my xy axis, suppose I have a vector which when I draw it from the origin, it looks like this. This vector E, it makes some kind of acute angle with the x-axis and its magnitude is E. Then in this diagram, I can see that if I drop a perpendicular from the vector E onto the x-axis, then I can represent this so I can represent this length over here as Ex from here to here. And similarly, if I drop a perpendicular on the y-axis, then I can represent this length from the origin or the base of the vector as the quantity Ey. And therefore, I can represent the vector E as the sum of this vector plus this vector. So it is Ex I cap plus Ey j cap. We are now using trigonometry here. You can see that Ex will be nothing but E cos theta. Because in this triangle, in this right angle triangle, you can see that what is cos theta? It is base upon hypotenuse. It is Ax upon E. The base of this triangle is Ax. So cos theta is base upon the hypotenuse, which is this capital A. And similarly, sin theta is perpendicular upon hypotenuse. So this perpendicular here is the same thing as this side Ay. So it is Ey upon it. So similarly, Ey becomes E sin. So this is the geometrical meaning of the components. That if the magnitude of the vector is E and the angle it's making with the x-axis is theta, then the x component is nothing but E cos theta and the y component is nothing but E sin theta. So this is the geometrical meaning of components. You just note this down. Alright, people, so hope this is clear. So for example, in this case, if suppose the magnitude of the vector E was 20 units and the angle it's making with the x-axis was, let's say, 60 degrees. So we want to write vector E in component form. So we use this formula that Ex is E cos theta, that is 20 cos 60 degrees, that will become 10, and Ey is E sin theta, so that is 20 sin 60, that would become 10 root 3. So the vector E would become Ex, which is 10 times I cap, plus Ey, which is 10 root 3 times. So this would become the same vector E in component form. So given any vector's magnitude and angle with the x-axis, we can easily find out its x component and y component using the formula that x component is cos theta and y component is sin. But here we should understand that what is theta? Theta is the angle of vector E with respect to the positive x-axis. Here theta is not the angle between A and B. Here theta is just of the vector A with respect to our positive x-axis. नहीं, I cap and J cap के लिए substitution नहीं बेटा. I cap and J cap is standard unit vectors. So that is why whatever the x component is, that goes with I cap because that is the component along the positive x direction. Basically, see what is happening that this. How do we interpret this quantity now? 10 I cap plus 10 J cap. So what is 10 I cap? It's a vector like this. It's a vector whose direction is along the x-axis and its magnitude is 10. Because I cap is a unit vector. What is 10 root 3 J cap? It's a vector like this. Its direction is along the positive y-axis and its magnitude is 10. So therefore, what is the vector E? It's becoming the sum of these two. So it's becoming this vector. So this is my vector E now, which is 10 I cap plus 10 root 3 J cap. So its magnitude must be how much? It should be the hypotenuse of these. So its magnitude we can see is 20. And this angle should be how much? It should be such that tan theta is this by this, so it must be 60 degrees. Okay. So let's quickly practice this out with a question. For example. So express each of the vectors shown in component notation, or sometimes we also call this I cap J cap notation. So we are using I cap and J cap. Okay. So let's say in this question, some vectors are shown to us in terms of the xy axis. So vector E is like this. So magnitude 15 degrees, 15 units, and this angle is 37 degrees. Then a second vector is shown to us like this. This one is of magnitude 20, and this particular angle is 30 degrees. Okay, and third vector is shown to us like this, and its magnitude is 10. So we have to do this. We have to express all three of the vectors in component form. Just try this out. Just express all three of these in component notation using I cap and J cap. Okay, so let me verify your answers. So for the vector E, you can see it's very simple. The magnitude is 15 and the angle is 37. So we can directly write x component as, when you do this, you'll get the x component as 12 and y component as, because cos 37 is 4 by 5 and sin 37 is 3 by 5. So you'll get the vector E in component form as 12y cap plus 9j. Very good, Aditya. Prince correct. Khushi correct. Now the story of B is a little bit more complicated. For B, you will have to understand that the way the vector B is drawn, its angle is lying in the second quadrant. So we have to understand that this angle for B is actually 120 degrees. And B's magnitude was 20. So for the vector B, the magnitude is 20, but the angle theta with respect to the positive x-axis is 120 degrees. It is 90 plus 30. So we'll have to use that relation, that cos theta is going to be cos 120, which will be minus cos 60. Minus, and sin theta is sin 120, which will be positive of sin 60. So it will be plus of, we have to use this value of cos theta and sin. So B's x component will become minus 10 and B's y component will become plus 10. That is why the vector B will become minus 10 I cap plus 10 root 3. Okay. So this formula, this actually also helps you understand this thing, that why, where this formula comes from. It comes like this, right? Because this angle is 60. So this x component of B, it's a negative quantity. That's why cos is negative. Whereas the y component of B is a positive quantity. So that's why sin is positive. Okay, people. So hope this is clear to all of you. Now the case of vector C is very simple. You don't have to bother much. Vector C, you can see, is directly along the negative y direction. So its direction is minus j. Vector C is directly like this. So vector C will be just written as its magnitude, but in the direction of negative z axis. You can see C's x component is 0. C's y component is minus 10. Okay, people, clear. So similarly, now suppose we had a vector like this. Another example. Suppose we had a vector which is like this. So this vector D, where this angle is, let us say, 60 degrees, and its magnitude was 50. So we want to express x and y components of. So how we do that is that we would understand that ये वाला एंगल कितना हो जा रहा है, this angle theta is 210 degrees. You can see it is 180 plus 30. नहीं बेटा, ये एंगल 30 है, this angle is 60, or it is 270 minus 60. This total angle would be 270, 9 to the 26. It's 210 degrees. Theta is 210. So you'll see that when you drop this perpendicular, and when you drop this perpendicular here, so D's x component becoming a negative quantity. D's x component is negative of, now because this angle is 30, negative of D cos, and D's y component is also negative. Sign. So that is why, in fact, we have this formula that cos of 210 becomes minus cos, and sine of 210 becomes minus sine. So D's x component becomes minus 25 root 3, and D's y component becomes minus 20. So the vector D itself becomes minus 25 root 3 I cap minus 25. This in fact even gives you formula for third quadrant. This gives you trigonometric formula for quadrant 3, that cos of theta can be written as minus cos of theta minus 180 degrees, and sine of theta can be written as minus sine of theta minus 180 degrees, and therefore tan of theta becomes positive of tan 180 minus, sorry, theta minus 1. So that is why, for example, cos of 210 degrees here becomes minus root 2 by 2. Sine of 210 is minus half, but tan of 210 will be plus of 1 by 2. So you have that ASTC rule which you must have studied in trigonometry and maths. The third quadrant tan is positive. So you can see the justification of that from vector algebra. So hope this example is also clear to you. Yeah, Dushyant, what you're saying is correct. This thing 210 can also be written as minus of 1 degrees. Okay. But the anti-clockwise of this can also be written as clockwise of this. Okay, good. So this process where we are writing a vector in terms of its x and y components. It is called resolving a vector. This process of when we say that given the magnitude of a vector and theta, we want to express the vector E as components. When we want to find out Ax and Ay. So Ax is given by this formula A cos theta, and Ay is given by this formula A sin theta. This process is also called resolution of a vector. Into its components. So if you see in some reference book or something that resolve a vector into components or do the resolution of a vector into components, this is what it means. Okay, people, is this clear? All right, now just the last thing we'll see for today is that we're doing addition of two vectors in component form. It becomes very easy. There's some internet issue happening. Are you people able to hear me properly? Because I think my internet is intermittently going on and on. Okay, good. Because suddenly there's a lot of rain and wind in my area. But anyway. Yeah, I'll show the upper note of it, but let's see this. So if we know the vectors in component form, what we do is we write it like this. Yes, it becomes. Now next we will just apply like normal mathematics. We will take I cap common and j cap common. So this will become ax plus bx I cap plus ay plus by. So this becomes the formula for E plus B. And very similarly, if I put a minus sign in between, then ये components के बीच भी minus आ जाता है. So the corollary of this formula is that if I'm doing the difference of A and B, then that becomes Ex minus Bx plus Ey minus By. Just make a note of these two formulas. Right. So let's now quickly understand this with an example. Suppose I have then I tap. I have another vector B, which is 30 I cap plus 40 j cap. And R is equal to B plus R is the resultant sum of it. Then find R expressed in component form. and secondly, the magnitude of R and R's angle with respect to the x-axis. Just try this out, people. This will be the final question for today. Yes, very good, Aman. You can see that R being A plus B. So it is 10 I cap plus 30 I cap plus 40 J cap. You just open this bracket, so it becomes 10 plus 30 I cap. So this is like our normal algebra. So we will do taking terms common and all that. So it becomes 40 I cap plus 40 J cap. So this is R expressed in component form. This is the answer to the first part. Now for the second part, all we have to do is draw this vector now with respect to the xy system, and we'll understand both its magnitude and its direction. So this is our standard xy axis. So in this system now, how is the vector R looking? So its x component is plus 40 and its y component is also plus 40. So R का जो x component है वो भी 40 है और R का जो y component है वो भी plus 40 है. So the vector R must be which one? Must be this hypotenuse. Yes. The vector R now must be this one. Okay. Such that if this angle is theta, R cos theta is Rx, which is 40, and R sin theta is Ry, which is 40. So these are two equations. Now if you just divide the two, you will get tan theta is equal to 1. That is showing theta is equal to 45 degrees. And if you just square and add these two equations, equation 1 square plus equation 2 square will show you that Rx square plus Ry square, this becomes R square. So the magnitude of the vector is square root of Rx square plus Ry square, which in this case is 40. So that's the magnitude. So in general, for any vector, we can say that for any vector A, which is Ex I cap plus Ey j cap, the magnitude of the vector is the hypotenuse of a triangle with Ex and Ay. Okay. And the angle it makes with the x-axis is such that tan theta is equal to Ey by Ex. Just as over here, tan theta was Ry by Rx. Alright, people, so hope you've understood this. Very good. So most of you got this correct also. Okay. So this is where we will conclude today's lecture. Now I have sent you an assignment on the WhatsApp group. Actually, all these assignments are supposed to be uploaded on the website, but I think last 2 or 3 days some internet issues have happened, and so it's not come on the website. So please try out the questions of that worksheet which I sent, the vectors worksheet 1, and we will start the next lecture with the discussion of that. So between now and next week, if you have any difficulty with any of the questions in the worksheet, you can just send me a WhatsApp message with that question and I'll help you out with that. So please try out all the questions and discuss all the difficulties. That's it. Thank you, people. Bye.